and our responses, particularly in the light of freshwater and carbon. And that's fantastic and essential, of course, but it's very easy to lose sight of a couple of things. One is that people need to be able to farm profitably, they need to be able to farm productively, and they need to be able to fit farm systems to the land and the climate and the people in a way that provides the best outcomes. And that is, and this is where I'm heading, that is a complex jigsaw puzzle. Right? It's not easy to kind of say how do we fit a farm system best to the land and everything else that goes around that. And it's very easy in today's world of sort of 20-second sound bites to look for what's the silver bullet. Oh, we just feed our cattle seaweed and we'll be right, or whatever else it might be. And we know that farm systems are complex, they have feedback loops, it's not that simple. And today we have some people in the room who have some fantastic experience and some learnings from working through farm systems in both a research and a practical way. So we're very excited to hear from those people. I'm going to invite Graham Ogle to come up now, and Graham's going to jump up and down during the day introducing people. I guess Graham has done a lot of work in recent weeks working with many of you, organising today, and on behalf of Rezare Systems, we're very grateful for that work as well. Thanks, Graham.
Thank you, Andrew. Rezare's been planning to run this workshop for quite some time, and it's a real pleasure to have a room full of all the people we want here for this workshop. What I want to do is just cover why we're running the workshop and a little bit about how. I think this is a chance for... Rezare's been looking for the chance to have a bit of a, and I found the word the other day, a policy refresh, a strategy refresh, sorry. Very cool word. And we thought, what better way is there to have a strategy refresh than invite all the right people, and we think you're all the right people, to a venue and talk about what we see as really valuable to farmers. What is value? What is value when we say, of all the things we can provide a farmer, what are the valuable things? I guess I started my career, my idea of that really was forged out of when I started my career in the 1980s, which meant that I had 2 decades of excruciatingly low product prices to work with for farmers. I remember sitting with a farmer one day, he was in trouble, the farm was going to get sold up, and I thought, if we get $35 a lamb, you'd be right. And of course, the markets weren't delivering that. Now, you can adjust that by whatever you like, whatever inflation index you like. The CPI would mean that farmers today would be getting $55 a lamb. And I imagine our budgeting would be even more difficult today given the increase in costs. Dairy farmers were getting $2.40 a kilo of milk solids. I mean, it's almost unheard of. And if we ramp that up by the CPI, we'd be talking about a payout today of $3.70. So this was a sort of the anvil that forged my early career, and going out to do things for farmers that were of value. The biggest value we could do for farmers then was increase their profitability, and that started to address all the other problems that were on the farm. So when Rezare set out, as we did in 2004, as a group dedicated to agricultural software development, often we sit around and think, is our strategy aligned with where the value is in the industry? Are we aligning our investment in resources where the value resides in the industry? So what we're going to do today is we're going to think, how might we align our investment with what top farmers are saying is important to them? And I can't think of any better way to start this workshop than listening to some top farmers. So that's what we're doing. I think consulting is also an extension of farming, and we'll listen to consultants after that. The farmers that we'll listen to have been through some process of change or intensive planning. And it's from those discussions that we hope you'll pick up some things about what they value. And maybe a successful outcome of this workshop is if you go home and think, hey, maybe we need a strategy refresh as well. So our next speakers, both Ravensdown and Balance, two different slots. You know, I just got to say to both Ravensdown and Balance, you know, you do a bloody good job. If anything, when I've worked on a farm and a Balance rep or a Ravensdown rep's come along and given soil recommendations, and I've done my own estimation, I always put on more than you guys do. You're missing out on some revenue. You should use my model. Okay, so both companies are doing some really interesting things, and I'm really looking forward to hearing about them. So our next speaker is Alister Metherell. Welcome, Alister. I've worked with Alister ever since Ag Research. I don't know how many years we're talking about now, but 1995. You know, I said to my son the other day, I said, yeah, well, that was before I turned grey. And he said, well, what happened when you turned white?
You know, one of the good things about working for a cooperative is actually you're working primarily for the farmer rather than for the company that actually, you know, has a pure profit motivated. So we don't always necessarily have to sell more fertiliser. Sometimes the answer to the farmer is, well, actually you might need less fertiliser, or quite often is you could use that fertiliser spend more wisely. And that's what the outcome of this project is frequently. So it's the Ravensdown Primary Growth Partnership, pioneering to precision. So first of all, acknowledge my Ravensdown co-authors, Mike White's down the back, so if there was a question session, you could have asked him. And colleague Ants Roberts, but also many other collaborators in the project, particularly Massey University, who have done most of the hard work around the remote sensing. Ag Research have provided a lot of the field work, and Rezare Systems, who have helped us with a lot of the modelling. So the challenges in hill country farms, there are lots of different landscape units. Is this a pointer? Maybe not. Is it? No. Anyway, you can imagine that if you're on this farm, different areas of the farm have got lots of different productive potential. So there's some relatively highly productive flats there, ranging to some stuff that you wouldn't want to put fertiliser on at all. So there's a lot of variation. There's also, and within that variation there's going to be different soil fertility levels, and traditionally we're going to take a few soil test transects across the farm, almost always never enough to represent the variability there. And there's also some environmentally sensitive areas, so there's areas around the river which we want to be careful about, you know, avoiding with fertiliser. So there's a number of different challenges, particularly in these hill country farms, that we're aiming to try and get some technology to get a better outcome, both sort of from productive, financial point of view and environmentally. So, can't quite even remember what the next slides are. Hold on, we'll find out. If I can even get it to change. Down arrow, there we go. So, the concept is to use remote sensing, in this case from an aerial-borne, aircraft-borne sensor, which I'll talk about a little bit more in a minute, to provide us with a complete soil fertility map of the farm. So we've got that complete coverage. Then taking that information into integrating that into a decision support package, pulling together quite a lot of different components to produce a fertiliser plan, which we then upload into the aircraft, and with some really smart tech that's been developed for the aircraft, we can apply fertiliser from the aircraft much more precisely than we used to be able to do in the past. And the outcome of that should be greater production and profitability on parts of the farm where they're going to get a good response to fertiliser and less nutrient wastage where it's not needed. So the remote sensing, it's a hyperspectral camera in a small plane, flies about 600 metres across the landscape, and it has a resolution of 1 metre squared. So basically for every metre squared we get a bunch of data. So there's a spectral signature shown there. There's actually 448 different bands of information. It covers from the visible through to the shortwave infrared. So you can see there on the graph what you can see visibly, and then you can get cameras with near infrared that you might be able to fly from a drone, only giving you a very small range of that information. Even the space satellites are still not going to give you the range of bandwidths that we've got here. From that information that's collected by the camera, there's been a massive program of calibration of that data against the soil fertility levels, the plant and plant nutrient levels and the soil fertility levels, to come up with basically an artificial intelligence derived algorithm to help us predict the Olsen P status across the landscape. So as a case study, I'm going to present some results from Paritapu Station. Acknowledge the Bruce and Doug McKenzie. This it's one of the properties that's been integrally involved actually in all parts of the program, along with a number of other farms. We had about 8 farms across New Zealand where we initially collected our calibration data set, and then we've added other farms in as focus farms to test the concept, and other farms that we've surveyed as validation farms. So Paritapu Stations in the Wairarapa area, southeast North Island, reasonably large hill country farm, 2,600 hectares, but only about 2/3 of that is effective area. There's a lot of bush areas carrying quite a number of stock units, but different parts of that farm have different potential production and therefore nutrient requirements. From the remote sensing, initially we get an estimate of Olsen P for every metre square, but that's sort of not quite so useful. We really need to generalise that up to a scale which we can start to interpret and use, and so we produce a map of the predicted soil fertility across the farm. Then we have got a sort of another arm of the project where we're modelling the potential pasture production, because that is a key driver of your nutrient requirements as well. So we've got parts of the farm flats that are highly productive, ranging through to some fairly steep hill country. So we're taking into account the soils, the climate, the aspect and slope factors in the pasture growth forecaster to predict the potential production, and combining that with the soil fertility information through econometric modelling, which then also takes into account the cost of fertiliser and the economics of the farm system using gross margins per stock unit, and that predicts our optimum fertility status. So that optimum fertility status might be higher, the same as, or less than the current fertility status as estimated from the remote sensing. And that's taken into account for a proposed fertiliser plan. So we need a certain level of generalisation to have something that's actually practical to apply as well. We take into account any environmental constraints, areas where we don't want to put fertiliser, riparian zones and areas around, you know, houses and buildings and what have you in the mapping as well, to produce a plan. The financial feasibility of the plan, of course, is also really important in discussing that with the farmer, and we have the ability to do what would be the optimum fertiliser plan with constrained expenditure as well, and come up with your initial requirements, which may require some capital, maybe some withholding of phosphate in some areas. You may need to choose different product, some parts of the farm within reason, because you can't have a whole range of products all being flown onto a farm. But if you've got a large area that, say, doesn't need current phosphate but still needs sulphur, then you'd use a sulphur fertiliser rather than a phosphorus fertiliser or a sulphur super to provide a little bit of maintenance P. As I mentioned, the technology in the aircraft, there's been some significant developments there, and by one of our colleagues, Rob Murray, has had a major role in developing the improved controller in the aircraft, so the hopper in the plane can open and close much more responsively in relation to the plane's position in the landscape and its airspeed, sort of predicting ahead of the plane where the fertiliser is likely to fall. So with that, we can be much more precise at applying different rates to different parts of the landscape and avoiding the waterways and that sort of thing. So all in all, this is pretty exciting. It actually brings together stuff that personally I've been working almost my whole career on in bits and pieces. The concepts aren't really new, that different parts of the landscape have different fertiliser requirements. That was, you know, sort of my colleagues were talking about that in the 1980s and the modelling that was developed at that time, and then further improved through the 1990s when the econometric model was developed. What we're doing now is bringing all those technologies, that technology and ideas together with some smart tech from the remote sensing and the ability to apply the precise plans, fertiliser plans by plane, have a much better outcome, and so we can do this stuff a whole lot smarter to achieve the outcomes that we're all looking for. So thank you very much for listening.
So I guess, stand in front of the microphone, just a few reflections on the day, and I'll keep this brief. So the first thing I thought about was the messages from our practitioners in the morning sessions. So the people, the farmers and the people who are working closely with farmers. And they talked about, unashamedly stolen from your slides, folks, people, planet, performance, and I've just kind of expanded those out a bit more. We talked about the importance of people, and I think we've reflected on that during the day. There were questions about what's stopping data interoperability, and the answer was people. There were questions about how do we get adoption. We talked about the need for specialists, and so a lot of it comes back to the importance of people in our thinking. Mathematical equations are great, but people are very important. Planet, we've talked about the need to make sure that we're farming within the constraints that we've got and doing the right things for our land and our planet. Performance, and I've added, and productivity there, and you know, Martin's questions are good ones. We want to include, we know we often fall into talking about improving production, right? And we know we don't want to talk about improving production, we want to talk about improving productivity. The measure of what we're getting out, and the bottom line measure of that is profit, as long as the other factors are equal for the amount of inputs put in and for the amount of emissions going out. Then something that I got out of those farmers who talked this morning is their strong emphasis on planning, on the processes that they and their teams follow, the communication of those processes, and the precision with which they go and measure. They identify what are the important things for them to measure in their systems, and they go and measure them. And together that, you know, that was talked about as systematisation, turning things into a system that's repeatable, and I think that's key. So some great learnings for me in those areas today. We talked, for those who are involved in research and in governance, we talked about capabilities. And I guess my reflection, thinking about some of the presentations, was the amount of amazing capability that we've had leveraged in this sector over many years in our science R&D and all of the things that underpin that. Some fantastic capability. And I think that goes to the heart of what you were talking about before, Graham. Other countries are investing in their core competencies, and in New Zealand we've made a lot of investment, not enough, but a lot of investment in building capability in pastoral agriculture and its underpinnings, which has been fantastic. There's some really valuable collections. We talked about the virtual climate stations, we talked about S-maps, and we've talked about some of the other collections that are out there. I didn't want to just say databases because there's a lot more than just databases. Almost every speaker talked about the opportunity to collaborate further, to engage further, to use data from other sources, whether that's climate stations or soils data or any of the other data sets that are potential to use, and the opportunity to engage together. And we see that in some of the collaborative projects that have been done. We talked a little bit about data integration, and to me there's some real benefits in being able to link data and to have common identifiers and all of those necessary things that make it easier to connect the dots between systems, and also consistency in meaning and interpretation, and are we talking about the same things? And then this afternoon we talked about our, and you know, I'm playing some fun games here, but we talked a little bit about sensing. We started off by talking from space, which is very much built on sensing technologies. But I thought, particularly when I was listening to Dean as well, that's another great example of sourcing data so that farmers aren't having to go and measure it. You know, imagine if you as a farmer, and farmers did have to do this, some still do, go and attend every sale yard that they can so that they know what the prices are. Try and keep their own little book so that they know where prices are heading. But there are tools that can deliver that data just as space can deliver pasture cover data. And I think we saw through the work that Ravensdown Balance are doing a bunch of other sensing and use of predictive tools to take some of the effort that farmers would have out of sort of capturing data and making sense of it. A lot of the tools we looked at, including FarmMax and including the tools that Ravensdown Balance have been working on, have been around making predictions that help people make either recommendations or decisions, and that's really powerful. And I think there's been a thread of discussion going through around, well, how do we then extend those services out? If you've got other crops you want to measure with space, how do you do that? Can we extend those services? If you've got some data that's in FarmMax or one of these other tools, how do we make it available? How do we make data flow into FarmMax? I think my other observation is that we're still at the stage where many of these tools, maybe space being an exception here, require the assistance of somebody, a specialist, to help interpret them, right? Whether that's a rep or an agri manager in a fertiliser company, and we know there's good reasons why we should be doing that, or a consultant to help you with FarmMax. And I'm not saying, we know those roles are essential and important, but if we're to move to support for adoption and use, we need to think about how we kind of leverage the time of those people, right? So that they're doing the things that only they can do, and that our tools and our systems are easier to use so that specialists don't have to get involved at every step in the way. So I guess that's my kind of reflections on what we've talked about today. I hope that, like me, this has been of interest to you, that you've had your eyes opened to some interesting things that people have been doing and some opportunities. I think it's been great to have the input from the farmers and the practitioners to kind of ground truth what the problems are that we're trying to solve. And what we're hoping is that this conversation continues on. So if you're on Zoom or if you're here in the room, hopefully you've made some contacts or you've made some notes of people you should talk to, and we'd really encourage you to continue to do that. If there's any way that Rezare can facilitate those discussions for you, we're happy to do that as well. So thank you very much.